Very good morning, friends. In this video, we will discuss the topic of digital twins. It is an upcoming research area in which a lot of fields have been combined. And let us begin with the concept of digital twins. So, in digital twins, what we have is the topics that we will discuss are what is a digital twin, how it is different from existing technologies, what are the enabling technologies required to implement the digital twin, what are the applications and what are the challenges that are there in implementation of a digital twin. So coming to what is a digital twin is a digital representation of an entity. For example, if we talk about a human being, then in psychology, suppose I create a replica of a human being and I give it all the characteristics, likes, dislikes of that human, then I can predict in advance that how that human will behave in a certain situation. This is one application. Another application could be for a machine. I can create a replica or a digital twin and I can predict that how that machine is going to behave, what are the faults that I can face, what are the design issues that can be there. So in this way, similarly, we can create a digital twin of a city also, and we can predict that what all problems will be faced in creating a smart city or in a building, what all problems can be faced. So a digital twin can be of any entity. It can be a twin of a human, it can be a twin of a building, it can be a twin of an office setup, it can be a twin of anything. And this digital representation, it can be used to study the behavior, it can be used to predict the responses, it can be used to correct the design faults. So a lot of applications are there in the digital twin. Now these are some of the definitions that are given by NASA, Shen and Louis in the different research papers that have been reported. In the NASA says, originally the digital twin was first implemented by NASA when they created a spaceship and they wanted how that ship is going to behave in the sky, because that cannot be directly monitored. So what they did was they created a replica of that ship on Earth itself, and whatever data was being sent or received from the remote machine, that was given to its replica on the Earth, and they could understand that how that machine is going to behave while it is on the flight. So NASA was the first one to pioneer in the digital twins, and later on the concept has followed and has been developed by several definitions. Now the digital twin and a simulator. Now you will say that even a simulator can do this. We can find out what all differences, how the machine is going to behave. We can predict. So the simulator is a passive entity. That means it is not on work when it is being evaluated. Whereas a digital twin, it is an active entity. While the original device is actually at work, the twin is going to predict that what on the next second what is going to happen. But in simulator, it is a passive entity when we are not actually on the work and we are just trying to simulate in a lab environment. So twin is on the actual front where actual work is being done. Then the twin is going to interact with the real devices for which the twin has been created, and it will get the real data through the sensors, which is not there in the simulator. So twin is going to get the data from the real entity or its sibling for which it has been created. And the twin can have an effect on the real device. That means the twin can predict how the machine is going to behave, and then the user can give a command to the twin that you do this thing, and that command will be communicated to the real device. So that way the twin is in constant interaction with the real device for which it has been created. And twin can help in fault identification in the real device itself, which is not possible in the simulator. Then there are certain other concepts like a digital model, digital shadow and digital twin. In digital model, there is no interaction between the real and the actual entity. In digital shadow, there is a one-way communication. That means the data will flow from the original device to the shadow, but from shadow we cannot communicate with the real device. And in twin there is a two-way interaction between the real entity and the twin. Now the ecosystem. For creating a digital twin ecosystem, infrastructure is required, and we require connectivity, we require the protocols for interaction, we require discovery of the twin and discovery of the other devices, then sensing is required for collection of data, then how the responses are going to be communicated, then how the machines are going to operate, who is going to start, and so on, then how to adapt to the changes that had been suggested by the twin. Then knowledge is required, agency, that means autonomy is required between the twin and the real device. So this is the ecosystem that we need to create in order to implement a digital twin. The enabling technologies: cloud computing, IoT, multi-agent, sensors, blockchain, machine learning, AR, VR, big data, cognitive analysis. These are the various enabling technologies which are required for the effective implementation of a digital twin. So cloud computing, IoT, these are required for connectivity, multi-agents for autonomy, sensors for collection of data, blockchain for securely storing your data, machine learning for predictions, AR, VR for graphical interfaces, then big data for again storage of data and how the data is going to be cleaned and how the patterns are going to be recognized. And cognitive analysis means other intelligent AI concepts can be implemented into the digital twin so that it can make decisions. Now, the several applications in manufacturing and design, we can make use of the digital twin. Health and wellness, we can make use of the digital twin. And in communication, holography, augmented reality, online social interactions. Then robotics is an area, computer science research is there. Then smart cities, security and safety. Then transport and energy, scientific research like biologists or biosensors. Then e-learning, finance management, virtual tours, e-commerce shopping. So a lot of applications are there for the digital twin. Now, what are the challenges? First of all, in a digital twin, the mathematical model needs to be developed for the actual application. That means the replica is going to estimate the responses based on certain equations and certain mathematical modeling. So, since the model cannot be actually real, we have to minimize the difference between the real and the model so that we can actually predict what is going to be the outcome of the real entity in a certain situation. Then data related issues are there because in digital twin a lot of data is required. Then there are country barriers. Then what is the frequency or the rate of capture? Then too much or too less data is there. Then what are the metrics for the data? Suppose we are collecting, the sensors is collecting in meters, then the formula is for kilometers, then that kind of conversions have to be made. So a lot of issues are related to the data which are political as well as technical. Then some remedies have been suggested, like you can unify the data and the model standards, share the data and the models, and establish a forum. So this way a lot of efforts are being made in order to reduce these challenges. And then these are the references which I have referred: Wikipedia, then Siemens, then there are other authors like Sommer, Moya, Sommer, Muller, then Mala, then NL. This is a document by one of the forums. Then other authors are there who have mentioned that what are the definitions or applications of a digital twin. And I also have a publication related to digital twin which you can find out from my Google Scholar account. And I hope this video is useful to you, and you will benefit from this video and pursue digital twin as a research topic. And all the best to you. Thank you very much.